On section 3.2, we will look at the product and quotient rules of differentiation. In the previous section, we learned about the constant, the derivative of it is a 0, and then we also use the power rule. But sometimes we have functions that are really the product of two other functions, and so in order to find the derivative, we will be using this rule. Now that looks kind of complicated, but I want you to look at these words, and what does it say? That the product of two functions, the derivative, is the first function times the derivative of the second plus the second times the derivative of the first. So let's look at this example. What you need to recognize is that it really is the product. You actually have two options. You could multiply this out, that function, and then you just apply the power rule. So let's do that. We would have, again, if I bring this 3 down in front, that multiplies with the 3 in front. And then if I multiply this 2 times that 12. So that is certainly a very easy way to find the derivative. So you say, why would I ever use the product rule? Well, you'll see in a minute when the problems get harder. So let's talk about the easier ones. All right, so if I have, I'm just going to call these different things. I'm going to say this one, let's let that be U, and how about let this one be V. And then I'm going to take the derivative of each one of them. Now, this is a nice, easy process to kind of line it up. And then what you can do with the product rule is that you can multiply these in this order and add them together. So let's see. Now, we already know that the derivative using that is 9x squared minus 24x. Let's see if we get the same thing. So I'm going to have 3x squared times 1 plus 6x times x minus 4. Now, that doesn't look anything like that answer. Or but does it? If I distribute, I think you can see that it is the same answer. But personally, if I was working this problem, I would have worked it that way. And you have a choice. All right, so on this next example, again, I could multiply this out. It's not that bad, but let's see if we can use the product rule. All right, so I'm going to identify the product. Remember, that means to multiply. So I'm going to use my U and V thing. A lot of people use like first and second. That's okay. Then I'm going to take the derivative of each part. So remember, there's a 1 in front, so that's just 1. The derivative of a constant is 0. Okay, here, remember, we're going to bring down the 2 and multiply that. And so the product rule says to multiply the first one times the derivative of the second plus the second times the derivative of the first. So this is just a really nice organizational way to keep up with your work. So I have x plus 2 times 6x minus 5 plus 1 times 3x squared minus 5x plus 1. Now, I really don't know how much simplification you're going to have to do on the computer, but this would be a fine answer. But if we had to simplify it more, we would have to multiply this out and then just collect like terms. Let's see, that's 7x, that's plus 2x, I think, minus 9. But again, this is the derivative. That would be an acceptable answer. So this next one, again, we could multiply that out. It's really not that bad, but let's practice that product rule. So those are the products of those two functions. Now take the derivative, right? I'm going to multiply the first times the derivative of the second plus the second times the derivative of the first. Really should not matter what order you do this multiplication in. And I'm just going to stop there. That's good enough. All right, well, this looks like a very strange problem. Well, all they're trying to do is to kind of mix up what we learned in the last lesson and the product rule. So I know you should know how to take the derivative of that. That would just be the power rule. That's a constant. So right here, we would have the product. And again, you could multiply it out, but let's practice that product rule. So we would multiply, multiply, add those together. All right, so, but let's not forget the rest of the problem. All right, so I need to look at this part. So I'm just going to apply the power rule. Remember, the power comes down in front, times the 1/4 that was already there, and subtract 1 from the exponent. Now I'm going to use the power rule, so I'm going to come over here. The first times the derivative of the second, plus the second times the derivative of the first. Notice I'm putting the monomial in front. I just think it looks prettier. And then the derivative of 15 is really 0. Now let's just clean that up just a little bit so those 4's could reduce. And then I think I'm just going to leave this as is. I guess we could distribute that. And of course that's 0. And then maybe the last thing I would do is collect like terms. Now that's an ugly answer, but it certainly is correct, unless I've made a mistake. I guess you could multiply that out and collect like terms some more, but this is certainly good enough. Alright, so here they're throwing some square roots at us. Remember that the square root of x is the same as x to the 1/2 power. So again, we could multiply it out, but let's practice that product rule. So there's my first function, there's the second function, taking the derivative, bringing the power down in front, subtracting 1 from that power. Then the derivative of 2 is just 0, right? So I'm going to take that, multiply that, add that together. Okay, so times 6x, just to be prettier, I think I'm going to stick that in front. Now, that's not a very pretty answer, but it certainly is correct. I'm just going to clean it up a little bit. Since my problem started out with the square root, I think that's how I'm going to write the answer. And again, I could keep this other part just as is, but I'm going to take that negative exponent and I'm going to move it to the bottom, and so that would be a x to the 1/2 on the bottom, which is the square root of x, and that's how I'm going to leave my answer. But in truth, the original one should also be correct. It's just a matter of how much simplification you want to go, and I'm not going to require that much. So now we have, again, the product of two functions, but I can't use the power rule when the x is in the denominator. So I'm going to pop it up to the top and change the sign of the exponent. Right? Then the derivative of a constant is 0. And the other one I have negative 2x to the negative 3. Remember, when you subtract 1 from a negative, it's going to be more negative. So I want to multiply, multiply, add those together. All right, now since I'm going to do this product and it's negative, I'm going to just take that negative like that. And again, that would be an okay answer, I think. I certainly would count it right. But if I wanted to rewrite it without negative exponents, again, I would take them and do the reverse. The negatives go down to the bottom. Now, if you're asking why did I not take the 2, that has a positive exponent, so it stays on the top of the fraction. Okay, that should be acceptable. You could FOIL it out, collect like terms. There would be another acceptable answer. You can just do lots of algebra. So now that we've seen the product rule, we're going to look at the quotient rule. And this looks pretty scary, I admit, but it's when you have two functions being divided. And we're going to look at the top versus the bottom. All right, so we have this very complex expression. I want you to notice the minus sign because that's what gets the students. All right, so in words, we've got the derivative is the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, and then you've got to remember all divided by the bottom function squared. So just like the product rule, I had a little organizational thing with the u and the v. We're going to do the same thing with the quotient rule. Now, as we look at this first example, again, there's lots of different ways to do this, but we're going to practice the quotient rule. So we're going to say t is for top and b is for bottom. All right, so we're going to take the derivative of that constant as 0. This is just 2. So this is a pretty easy one. So now, well, we've got to multiply those two things, but we've got to do it in the right order. So let's see. It is the bottom function times the derivative of the top function. So we've got to do this one first. So I'm going to say 0 times 2x plus 4, all right, minus the top function times the derivative of the bottom function. So I'm going to do that second. 3 times 2 is 6, divided by the bottom function squared. So of course 0 times anything is 0, so I have negative 6 over 2x plus 4 squared. You know, since we have to do the bottom function first, how about let's start there. All right, so I'm going to take the bottom function, the top function, and again, that might be a little bit easier, alphabetical. B comes before T. All right, so I'm going to take the derivative, don't lose that minus sign. And so the rule says bottom times the derivative of the top. So I'm going to write that down. So I have negative 2 times 1 plus 3x minus the top times the derivative of the bottom, all divided by the bottom squared. You can clean that up at the top if you want. You can leave it like that. Doesn't really matter to me. I'm going to go ahead and make that a little bit prettier on top because truthfully we need to practice some of those algebra skills for future problems. All right, so those are going to reduce and we get that assuming I've not made any mistakes. Again, let's just do that alphabetical, the bottom, then the top. Take the derivative of each. I'm hopefully remembering that the derivative of those constants is 0. So my overall derivative is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And again, you can leave your answer like that, or you can FOIL out the top part and collect like terms, whatever you feel comfortable with. But I have checked it on the computer. It will accept something like that. So now we have that square root again. So that bottom is the square root of x, which I'm going to write as x to the half power. And the top function is x cubed minus 12. So bottom times the derivative of the top minus the other way. And then don't forget the bottom squared. Okay, so the bottom, remember, is the square root of x squared. Now I think we could clean that up just a little bit because we know that's going to be just x. And let's see if we can combine these exponents. Remember, you keep the base and add, so that would be 5/2. That, I certainly could do a lot more algebra, but then I'm going to take that square root of x and square it. And I'm going to leave my answer like that. Pretty ugly, but certainly can be left like that. Okay, so now we're asking to use the derivative. Let's see, find the derivative at a certain value. And so we're just going to, let's see, is that a product or is it a quotient? Well, it's the product. And so I'm going to use my product rule. Remember, the square root of x is x to the half power. We've been doing the quotient rule, so let's go back and remember the product rule. Remember, we multiply and we add. All right, so my general derivative is as follows. Pretty ugly, but now what do we need to do? We need to plug in 4 for x. Okay, so remember x to the half, that would be the square root of 4. Ooh, now this is pretty ugly here. Now remember, a negative can be bumped to the bottom, so that's really the square root of x on the bottom. So in this case, the x is 4, all right? And what does that mean? Well, this means the square root of 4 cubed. The bottom number is the root, so that's the square root, and the top number is the power, so that's why we're cubing it, and x is 4 again. Okay, the square root of 4 is 2, cubed is 8, minus 4, that's 4, so that's 20 is 28. Again, you're certainly welcome to use a scientific calculator to help you out, but you really should know that halves means square root, what is the 3/2 power, all of that. Okay, and of course we're going to be asked to find the slope and equation of a tangent line just like we've done. Okay, so in order to find the slope, we have to find the derivative. We'll look at that function. It's not a product, it's a quotient. Take the top, and remember we're going to change that square root to a half power. All right, so let's see. My derivative, remember, is the bottom times the derivative of the top minus that, all divided by the bottom squared. That's pretty ugly. Okay, but that's the general slope. Now I need to find the slope at the point 4. So pretty much just like last time, we're going to let x be 4. All right, so remember we have a negative, so that's going to be 1 over the square root of 4. 1 plus the square root of 4 cubed. Okay, so what have I got here? Square root of 4 is 2, cubed is 8. Square root of 4 is 2, so those would cancel. Square root of 4 is 2 times 2 is 4, plus 1 is 5. Again, 1 plus 8 squared. So this is looking better. Okay, that's going to be 9 squared is 81. Okay, if you were to use a decimal, it's going to get pretty ugly here. You really need to kind of keep it in fraction form. Calculator might be very helpful. Alright, so that is the slope of the line, of the tangent line at that point. What else do we need to know? An equation of the tangent line. Alright, so I have the point 4 and 5/9. Okay, so we have y minus 5/9 equals your slope, which is negative 7 over 54 times x minus 4. Now that's pretty ugly, but we're going to multiply each side by 54 to get rid of some of those fractions. So we have 54y, and then 9 goes into 54 6 times, so that's 30. And those cancel, and I'm going to distribute the negative 7. Start solving for y. Add 30 to both sides. Then the last step is to divide by 54. And I believe we can reduce that by 2. So it's at 29 over 27. Okay, so the next one says, find the points on the graph where the tangent line is horizontal. We did this in the last section. That means that we want the slope to be 0. So that means the slope is the derivative, so I've got to find the derivative of our function. Notice that it is a quotient, so I'm going to use my quotient rule. So I have the bottom function and the top function. I have to set that equal to 0 and solve for x. Well, let's see. So I've got, now that looks kind of scary, but let's just kind of remember that we can cross multiply fractions, and I'm going to collect like terms. So 1 times that, but then 0 times the denominator is 0, so that's not so bad. Right, so I'm going to add x squared to both sides. I'm going to take the square root, and don't forget that the square root is plus or minus 5. Now that's not all of it. It says to find the point, which means I have to find the y values as well. So I go back to the original function, and I'm going to substitute in 5, and then I'm going to substitute in negative 5. Don't do it all at one time. So 1 point is when x is 5, y is 1/10. And of course, when you square that negative, you get positive. So the other point is when x is negative 5, y is negative 1/10. Now, just because those end up being plus or minus, that's not necessarily always true. All right, so now instead of finding the points on the graph where the slope is 0, we want the slope to be negative 1/2. So the process is the same. We're going to find the derivative, set it equal to negative 1/2, solve for x, and then get y. Right? So we have, again, a quotient. And so my derivative, and notice I always put parentheses with that minus sign. That's a good habit to get into. Okay, so if I collect, so let me now distribute that minus, and let's see what happens. The x's add to 0, and I get this expression. That's my derivative. That's the slope in general. Now I want that slope to be negative 1/2. So I'm going to take my derivative and set it equal to negative 1/2. And just like on the last example, I'm going to cross multiply. And I'm going to now divide by negative 1, so they're both positive. Then I'm going to take the square root. So again, that's that plus or minus 2. This is where you've got to be careful here. So we're going to have plus or minus 2 plus 1 is equal to x. So 2 plus 1 is 3, but negative 2 plus 1 is negative 1. So I have 2 values for x. That means I've got to find 2 values for y. So I've got to use my original function, right? So I'm going to substitute in 3, and so 1 point is that. And I'm going to substitute in negative 1. And so I get the point negative 1, 0. So these would be the 2 points on the graph that would give you a slope of a tangent line of negative 1/2. And here's your hint on number 23 on section 3.2.